This will be a quick discussion regarding pressure altitude. Pressure altitude is a performance term. It's defined as the indicated altitude on an altimeter when using the standard altimeter setting of 29.92 inches of mercury or 1013 millibars or hectopascals. What we're going to do is discuss the effects of its performance in very detailed fashion in the course. Right now it's just a little bit of an overview as a sample podcast. But the pressure altitude is a term that you're going to see in limitations. The aircraft that we're going to use in the course, for instance, has an altitude limit of 8,400 feet for takeoff and landing. What that means is the aircraft, if it has a pressure altitude measurement of 8,400 feet, they're at limitations and can take off. If it exceeds 8,400 feet, it cannot take off. Pressure altitude, and they're quite simple to remember. Just think of the term pressure, altitude. That's it. Pressure and the altitude. If you know the elevation of the airport, the altitude basically, and the pressure, which is going to come from the altimeter setting, you can use mathematical computation to determine the pressure altitude value. Without getting into math in a podcast, basically it works this way. The lower the pressure, the higher the pressure altitude. It might sound a bit like a contradiction, but remember, where do you usually encounter lower pressure in terms of altitude? At higher altitudes. That's where we have less density and lower pressure. During flight planning, what you'll notice is when we read weather reports for departure, you'll see altimeter settings that may occasionally be below standard setting. In other words, they may be 29.52 instead of 29.92. Well, that's immediately recognizing lower pressure and a decrease in performance. How exactly you're going to see that decrease in performance will be reflected in the limitations. For takeoff, for instance, you're going to have a penalty. You simply will look up the lower altimeter setting and then subtract a number of pounds from one of your takeoff limits. But essentially it's because of a higher pressure altitude effect from low pressure. That higher pressure altitude effect is going to reduce the ability to take off at higher weights. And one last point to make, the pressure altitude term is a wonderful performance index, a performance indicator. It basically, the value will tell you what your aircraft is performing at in terms of altitude based on pressure alone. That's really what it's going to tell you. In other words, if your airport is a 1,000 foot airport but the pressure altitude is 1,500 feet, the aircraft thinks it's at 1,500 feet based on pressure today. Must be a lower pressure. That's where you're going to have higher pressure altitudes. Therefore, the aircraft is performing as if it were at 1,500 feet when it's actually at 1,000 feet. You'll probably have a few hundred pounds to reduce to a typical jet aircraft for takeoff. However, remember, there's one factor we did not discuss in this entire podcast, and it's the most important factor for any kind of aircraft performance, whether it's climbing, cruising, landing at high elevation airports: temperature. The pressure altitude, remember, was defined as simply an indicated altitude using a standard setting. Pilot reads a dial. They can determine a pressure altitude simply by looking at a dial. We as dispatchers can determine it mathematically, which again we'll do in the course, not in a podcast right now. However, the density altitude is a different term, another term, and an even better index, because that is going to be the pressure altitude corrected for non-standard temperature. The density altitude is going to take the temperature into account and incorporate the most important factor for performance. The pressure altitude, however, is going to be noted on various graphs, charts, performance boxes, on flight plan forms. So it is one factor that we do have to tackle independently. However, later on you will tackle also the temperature and therefore the density altitude effects on the aircraft performance.